This is also the most people we've had in a long time, so I'm going to look at y'all back in the corner there. If I start to fade out volume-wise, like kind of wave frantically or gesture like an upward volume kind of motion. We do have sound system equipment, but I've tried turning it on repeatedly to no avail. So yeah, we have it and it looks great, but doesn't sound like anything. We are in the 8th episode of our little-known CSS Basics series, and some of you who have done CSS for a minute might be looking at Grid and asking, now why is that basic? So I want to start off by defending why am I including CSS Grid layout on the CSS Basics topic. This seems like a really advanced thing a lot of devs are used to. They say, hey, we just install Bootstrap and it floats everything for us. Or we've done Flexbox for a little bit, and that's kind of newfangled and cutting edge, and that's good, right? The reason why we're including Grid in a CSS Basics series is because this is the new normal. In a couple years, like IE11 will be a thing of the past. Microsoft has already said out loud, it's not a browser anymore. It's a temporary like Band-Aid solution. Opera Mini hopefully will eventually update with Grid support. They're kind of the last two big segments of web traffic that doesn't support Grid, at least partly. And IE11 even supports it partly. So this is going to be the new layout method. Everything we've had up to this point, some of you may know what that is. Back in the day, early 2000s, everything was in a table, and you had to put like images into table cells to make things be the right proportions, and that's basically still email development today. If anybody asks you to do an email development project, if you can say no, go for it. It's like developing for the web 10 years ago. So everything went in a table, and that's how you did layouts. That's your columns and your rows. And then we got kind of clever and found some new CSS and started doing things like floats, and that was kind of fun. And with floating, you could tell an element to scoot all the way to the right or left margin, and then other elements would just float around it, kind of cover the edges, and that was great, but you had to do all the math in your CSS, which meant if you had like a percentage-based column, but also like a fixed pixel gutter in your grid, you're kind of out of luck. You had to compensate with like padding inside, and then we got the calc function in CSS, and then you could do it back on the column itself, but that was hacky. And it worked great until you had to clear fix things, and then that was a royal pain, and you had to give up all of your before and after pseudo elements because they ran layout, they couldn't do visual things, and that was just a royal mess. And we started doing display inline block, and that was fun except for that weird white space issue, and you had to change font size or adjust line breaks in your actual HTML, and you were doing all these other workarounds to make inline block work correctly. And still, you had to put all these percentage-based widths or fixed widths on every element that fit into a grid. Every column needed to have the width math attached to it. And then we got Flexbox, and that was great, but Flexbox only goes one direction. You can let it wrap, but elements only go one direction. You can't do columns and rows, or rows and columns. You pick one, and it can wrap, but you can't force anything to line up. And that's kind of, in a nutshell, the history of layout in CSS. Everything we've had up until Flexbox was not really a layout property that we forced to work for layout. And now we're at the beginning, I think maybe a year-ish in, I would argue, to the new basic for CSS layout. Again, a lot of us are supporting legacy clients, we're supporting older browsers, so we like Grid, but we have to include a fallback, and if the fallback does the same thing, you might as well just write the fallback. Some of those kind of logistics and practicality choices, but from here on out, Grid is going to be the way we lay things out on the website. Grid is pretty amazing. Within a series of just a few months, all the major browsers shipped support for Grid and moved it out from behind flags. Browser vendors were like arm in arm locked together on let's get Grid out for CSS developers about a year and a half ago. It's a pretty powerful statement for what can happen if they actually work together instead of everybody doing a different prefix thing and hoping it all lines up in the end. So let's talk about Grid. And the first thing we have to do is look at a really cool picture of a grid. We're not going to learn how to make this picture of CSS, that's just a photograph. But we are going to talk about Grid, and we've got a couple categories of content for tonight's talk. And if you're used to like big fancy like 2 or 3 day conferences where every talk comes with a big awesome overarching narrative and all that kind of stuff, we're more curriculum-y here in this series. We're going to go through what does CSS actually give us? What are the property names for a Grid container? We're going to look at what are the new values we have, because they didn't just add new properties to CSS for Grid, they also added brand new values. Then we're going to look at the children, and how do you make the children go to the right place in that Grid parent. So before we jump into this, I've already hinted at it, but I want to make really clear like a mental shift for CSS Grid. With everything else, we did all the layout by doing all the math for every column width, everything we had on the children. We told the children what their flex basis was going to be. We gave the children a percentage width and we floated them, or we inline blocked them. All the math happened on all the children of the grid. And that was lowercase g grid before we had actual properties for it. In the new CSS Grid layout, all the math, all the fun stuff happens on the parent. And it's a really neat level of abstraction. You get to draw out the grid on the parent element, on the container, and then tell the children where to fit into that abstract grid you've created on the parent element. There's a whole flip in where the math goes, where the complexity lives. It provides us a lot of power. It makes a lot of responsive things easier and more shorthandable, if that's a word. It is for tonight. But we're going to look at how CSS makes our lives easier, and this is really going to be the foundation for layout moving forward in the web. So the first thing you need to know is display grid. That's kind of a pretty evident, self-evident one. What does a display grid do? It tells that element to create a grid layout inside of it and align all of its immediate children on that grid. And you may remember inline block versus block, or inline flex versus display flex. There was even inline table versus display table, if you ever needed to use that. And if you wanted to make a grid that wasn't block level, wasn't always defaulting to 100% wide, you can make an inline grid. And there's a CSS value for that too. And that just corresponds to block to inline block, grid to inline grid. It'll only be as wide as its contents require. It won't, like any other block element, it won't like a block element fill its entire parent width. So that's easy, right? Boom, we've got a grid container. What happens after that? All of these things. And this is why a lot of people come to grid and they think, oh my goodness, this is massive. These are so many different things. How do I memorize all of them? And we've also got a really neat complication here. If you're familiar with CSS and have been doing it for a while, you're used to hyphenated properties. But how many other properties do you know with 2 hyphens in them? Yeah, some of the font feature, font variation things, but most people just kind of use whatever comes with their reset or their boilerplate. All of these multiple column or multiple hyphenated things, it adds a lot of complexity right away. And it makes it feel like there's a lot to get your mind around to get started. And numerically, that's absolutely true. There's a lot of things going on here. So, without further ado, we're just going to go through these property by property and look at what each of them does. And the good news is, a lot of these overlap in what values they accept. So once we get the first couple of them in, we'll see a lot of repeated content, and it won't take us all night to get through this one slide worth of properties. So grid template columns. The word template tells us that what we're going to make is an explicit grid. That contrasts an implicit grid. Implicit grids let the children elements kind of form their own shape. It still does a grid layout. It will still line things up on columns and rows, but it allows the children to do a lot of things. The auto rows and the auto columns properties give us an implicit way of sizing grids. Template columns gives us really fine-tuned control over explicit grid measurements. Grid template columns, as you're probably already guessing, lets us set up the columns that children can be aligned to. It sets the proportions for tracks along the inline, or in a left to right Western writing mode along the inline axis of the grid container that's horizontal. If you were to use a writing mode, which also exists in CSS, that tilted everything 90 degrees, all of your grid layout would shift to match. That would all be great. If you switch from LTR to an RTL language, you're supporting a site or an app that's translated into Arabic or Hebrew, for example, grid will reverse itself. Whatever direction the axis goes, that's where the grid starts and ends. It's a really smart layout system. You don't have to rewrite a whole bunch of things inside of a direction RTL selector. And what are the values we can pass to the grid template columns property? Any series of valid length values. Whole bunches of them available. M's, rems, pixels, percents. You may see a value you're not used to there, the FR unit. We're going to cover that when we get to the new properties available to us. And what these do is these create a column pattern based on those measurements in a row. So the first value is going to create 4 columns in our grid. The first column and the final column will be 1 fractional unit wide. The second column will be 50 ems wide, and the third column will be 35 ems wide. The second one will give us 3 columns, 30% for the first column, 150 pixels for the second, and 30% for the third. And depending on the width of your grid, this may leave a bunch of empty space. If your grid is more than 450 pixels wide, then 150 pixels is way less than that final 40% you need. So you may have empty space. You can create a grid that doesn't fill the entire width of the container. Using fluid units, of course, gives you fluid things. Percentages flow. They're fluid fractional units, which we'll cover more in detail later. Those expand to fill the available room. But if you use a whole bunch of pixel-based things, you're creating a fixed set grid, and be aware that your responsive design will need to accommodate the total number of pixels you've defined. So that's how you set up grid template columns. Each value you put in that series is a column measurement, and it goes in order left to right or right to left if you reverse the language property. What's it look like? We got a little test it out box. The default value is just 1 column. Everything's 100%, unless you set something specific. So all 5 of my little boxes here have just turned themselves into implicit grid rows because there's no grid column for them to be forced into. The initial column value is just 100%.
So in the HTML, are these just like 5 divs underneath it?
Yeah, they're 5 whatever you want. Any element that's the immediate child of the grid container. Yep. And it will typically take even like inline elements and mess around with their width a bit too. It tends to, the default for aligning things in a track is stretching, and we'll get to that in a minute. So first option, we can create 3 columns, a fractional unit, 8 ems, and 200 pixels. And we're just mixing fixed and fluid measurements here. And that snaps to this. There are 6 boxes. The first one is 1 fractional unit, again that's coming in soon, wide. The second one is 8 ems, font size based unit wide. And the third column is 200 pixels wide. And no matter how many elements we keep adding to this grid, we can put 36 elements in there. And every first, second, third, first, second, third, first, second, third, without row wrappers like bootstrap, extra divs, without any of that, they're all just going to fit the grid. They're going to respect those column measurements. Yeah?
If you had an odd number, does it just fall into whichever order it falls? Would you have like a gap? You say you had 5
Yes.
elements,
If we deleted the 6th element here, it would stop at 5 and leave a hole in the grid.
Perfect.
Yeah. Yeah, Flex always wants to stretch things unless you do a lot of work to make it, set the right Flex properties that make it not do that. Grid preserves empty cells. We've got a function here called repeat, and we're going to create 3 200 pixel columns. And because they're using fixed column measurements and our container is too wide, so to speak, we left a big gap at the end. The container is actually something like 700, 750 pixels wide, so there's not room for anything beyond that. So these 3 200 pixel columns are respected, and the fact that we did math that left empty space doesn't bother grid. It'll respect our math and leave the empty space. And then 1 fraction, 2 fractions, and 3 fractions. You may be starting to get a sense on how a fraction works. That together makes 6 fractions. So the first column is 1/6, the second column is 2/6, and the third column is 3/6, or 6, a half, a third, and a half, if you like to simplify your fractions. And again, as many as we throw in there, they're always going to respect the same column proportions, no matter how many elements are in this grid. That's something that Flex can't give us unless we go defining precise widths on every single Flex child, like an nth child selector. Grid just does it by default. Yeah?
So if I had 1 FR, 2 FR, 3 FR, and 400 pix, would it subtract the 400 pix and then just use the remaining space to divide up those 6 slots?
Did you skip 7 slides ahead? Yeah, that's exactly what it does. It takes all the fixed measurements out, including fixed width, percentage width, gap. There's a gap property. And then whatever is remaining gets divvied up among however many FRs there are. FR doesn't have to be an integer, it can be a float too. So you like 1, 1.6, 2.6 if you have weird golden ratio things going on. Yeah, it does all that. Yeah, back corner.
I'm sure I'm skipping ahead a little bit too, but that fraction keyword, is that grid specific or is it specific?
Right now that's grid specific. There's nothing else that you can measure with a fractional unit. Alrighty, the next thing is the exact same deal, only it goes up and down instead of left to right. Grid template rows sets a proportion for tracks along the block axis, which goes top to bottom of that grid container. Again, same value, any series of valid length values. 300 pixels, 200 pixels, auto. Auto is a great keyword. You may have seen it in a few other CSS places. Auto just means whatever size that child is, we'll use that. And if there are multiple children in the row, whatever size we need to do for the largest child. All right, I've done a 3-column layout here just so things break into 3 columns. But with that repeated 3 columns, what can we do with rows? All right, first row is 100 pixels tall, second row is 150, and there's gap at the bottom. Grid doesn't care. The gap is here on height because I set a fixed height on the grid containers in my slide deck. If we had natural auto height happening, we wouldn't have the gap. The grid container would only be as tall as it needed to be for its children. We could do repeat 2 3M units, and now we've got 2 rows that are identical. They're each 3 M's tall. And then 1 fraction and 2 fraction. Here, because we have a fixed height grid, it divides the entire height into 3 fractions minus gap, and gives us 1/3 for the first row and 2/3 for the second row. And those are grid template columns and grid template rows. Any questions before I move on from that? That's all a lot of mathy stuff, yeah.
If you don't have a set height on the container, what if you only have fractions on your rows?
I've got a slide for that in a minute.
Okay.
Yeah, it's a great question though. Yeah. The grid template areas is awesome. It lets us assign names to cells, blocks of column row units in our grid, and we can stick stuff in those cells by assigning the child the grid area property. So here is, sorry for the back row, that's a little tiny for you. We're doing grid template columns. 1 column is 40 M, second column is 20. We're gonna do 3 rows. They're all auto height. And then I'm gonna name some areas. The first and second column in row 1 are both gonna be named header. In our grid, that's going to function like 1 block, 1 area, and any element we put in there is gonna take up the whole width as it needs to. Then in the second row, column A is gonna be the body, and column B is gonna be called sidebar. And then the final row is gonna be, both columns are gonna be 1 area called footer.
But just to make sure I understand, like
Yeah.
using the same name, you're naming it as one?
Yes, when you repeat a string that's a name, that makes it 1 unit. The rules for that are you have to make a rectangle and 1 rectangle only. You can't make L-shaped spaces, you can't do opposite corners. It has to be 1 single unit that is rectangular. Yeah.
Is that for each different worded string? Would that be like if you wanted 5 different columns
Yeah.
in like the middle, you could just have 5 different words?
Correct. Yeah, if we had 5 columns across here, we wanted the header to go all the way across, we'd write header 5 times in a row. We would write footer 5 times in a row if we wanted to span the entire 5-column grid width. And in the middle, we would put the right words in the right places for those column areas. You can also do fun things in, grid template. I love grid template. 1 more layer of combinification. This is a shorthand for grid template rows, grid template columns, and grid template areas. All the last 5 slides we've looked at, you can put those all into 1 property. And this is really neat because if you're visually inclined, you can basically draw like ASCII art of your grid, put it in 1 property, and call it a day. So it looks like this is an entire grid declaration, except for display grid, but we all assume that was there. So again, it's the same set of strings in the middle for our template area names. The same names, header, header, body, then sidebar, footer, footer. The auto at the end of each line gives that row a height. And then the 40 M's and the 20 M's at the bottom give each column a width. And that slash is important. That just separates between your names and row measurements and then your column measurements at the bottom.
You could inline that whole thing, but it would
Yes,
harder.
it'd be less readable and really long, but you could absolutely put that on a 1-liner if that were the way you wanted to format it. You can also do fun things in here like use emojis. Basically, the only any valid character is good except for integers. You can't use integers for grid area names because, as we'll see in a moment on grid children properties, if you use the grid area property, which is how you assign a child to its right space in the named grid, if you use an integer there, it actually treats it as a column start measurement because you can put numbers or names in that property. So if you're going to use a bunch of numbers and nothing like intentional, you have to put like a one-letter prefix on all those numbers. But yeah, so that right there is that's a full grid. Yeah, Corey.
May I just add something real quick?
Sure.
This is super nice for pairing up all the header name, the body, the side panel, the footer stuff with modules within your CSS with how you name things, and pairing them one-to-one with comments and all that within your code. Makes things super clear for the developers.
Yep. So if I were to jump ahead in the rest of my CSS, I would have, site-header maybe, and that would be grid area header. The content would be grid area content. My sidebar that would be in the side of the class, something like site sidebar, would be, again, grid area sidebar. And it would just jump in place. Or in this case, it would be grid area Wi-Fi emoji. And the cool part about that is when you get responsive, you can jump into a media query and you can rearrange this property on the parent. And as long as your names are the same, the elements will go to the right place and you don't have to change any child CSS in the media query. If you're using named grid areas, the only thing you have to change in your media queries is the grid area, the layouts and the names. And that's really powerful because, again, it's just so much less you have to repeat. If you're doing any kind of like float-based or even flex-based grids, whenever you get to the media queries and you want things to break lines, you've got to redefine each child width or flex basis or what have you. This lets you simplify, reduce drastically the number of things you change in a media query. Yeah?
Can you use the grid template values in a CSS variable?
Yes, I believe you can. I don't know any reason why not. I haven't tried it, but I don't know any reason why not. Which is one fewer thing you'd have to define in a media query. Yeah. If some of you have already moved that direction where custom properties are the things that change and your CSS doesn't have to get repeated. Yeah. So that's a grid template. That kind of boils down like one property you can lay out like as complicated a grid as you can imagine. And we've got some code samples later for some complicated grids that we could imagine. What if you just want stuff to happen and you don't have a really precise point of view on things? You're just making like an image gallery grid, or you just want things to lay out in columns and be the right height, that kind of stuff. You've got auto columns and auto rows as well. This sets one size, not a series of values, but one size to be repeated for all the tracks along that column direction, all the tracks along the inline axis. Any valid length value works. Pixels, a fraction is, kind of pointless since that's kind of the default. You wouldn't really need to write that down in your CSS unless you're redefining it like in a media query to change something. Auto, 20%. And now every column that can fit into there will have that measurement. This gives you kind of a neat, like already responsive kind of a thing, right? What if you do grid auto columns 200 pixels? As your viewport expands, you don't have to change any media queries. As many 200 pixel wide children as can fit into that parent's width as it changes, they're just going to start fitting. And we'll get into it in a minute, there's a cool way to make them resize a little bit to not waste space. And grid auto rows goes the same way, but up and down instead of left and right. Any valid length value, every row will get that value. This is great if you wanted to use grid to lay out a table, for example, of data. And all of your table rows needed to be 75 pixels or 50 pixels tall. Grid auto row is 50 pixels, and boom, every row in that table is going to match. Grid is our next property, and this is just like one big fun shorthand that I've never used in real life because it's too much. Just using the other properties explicitly makes more sense and feels more maintainable. But grid is shorthand for any pair of row and column values. That could be template row and template column, auto row and template column, template row and auto column, auto row and auto columns. Any pair of valid row column mashups, it'll take. And the syntax is just rows/columns. And again, it's tricky because, are you wanting things to repeat in an auto row? It's easier to make things explicit for you, the rest of your team who maintains it, if you just go ahead and use the template rows and the auto columns properties. You're typing more, but you got Emmet there to do auto completion, something like that in your editor makes it quicker to type. You can use grid if you want to. Again, that's an evaluation for you and your team. For me, it makes things slightly less readable, so I prefer to stick with explicit row versus column properties. But that's a preference thing. That's you and your team's code base and style guide. And now here's a fun one, gap. Creates gaps between columns and rows. That's pretty self-explanatory. If you've been listening to grid talks for the last few years, you've probably seen a lot of presenters show a slide like this, but it says grid gap at the top. What changed? Grid gap got deprecated. It's just gap now. Why is that the case? It's the case because there's a future thing coming where gap is going to be a Flexbox compatible property too. If you've been trying to do layouts of columns and gaps between them using Flexbox, you've had to use like space between on your justify content property, and you've had to like math all of your flex spaces to create enough pixel gap in the middle, and it's been kind of a royal pain. What if you don't want to do that? What if you just want to say a whole bunch of things should be flex basis 33.33%, and I want a 20 pixel gap though? In coming iterations of the spec for Flexbox will support gap as well, which is why they removed the grid prefix to get ready for it being a flex available property too. And this is a shorthand property as well. It stands for row gap and column gap. You can define them separately. It's a space separated series, no slashes. We had slashes between row and column measurements when we were defining rows and defining columns. There's no slash here. It's just row gap space column gap. The initial value is 0 pixels. There's no gap at all, but we can add 10 pixels everywhere, and that just happens like so. We can go with an M if we want it font-based, and an M looks much larger. You can even do 10 pixels between rows and 5% between columns. And the browser just does all that. It makes it, like, again, a lot of complicated stuff that we needed a lot of math and a lot of margins, especially the gap between rows. If you tried to do that in CSS with anything up to this point, you had to have bottom margins or top margins on all your elements, but then also figure out how many of them were in the top or bottom row of the container and remove their top or bottom margin, whichever you did. And that got into a lot of really complicated nth child stuff. And yeah, I've written like 60 character long nth child combinator selectors that do that, but it's not the right way to go. Gap is so much better.
So does your gap have, if I say columns 50%, 50%, gap 5%, does that 5% distribute itself across the 2 columns? Like, or will it, like the fact that it adds up to 105%, is that a problem?
Yeah. So if you define grid measurements that exceed the width of the parent container, your grid will hang out.
So
it'll slide off the edge.
50% gap 5% would hang out.
Yes.
Okay.
If you did one fraction, gap 5%. The 5% gap would be calculated first, then the remaining 95% would be divided into 2 fractions. So fractional units are a really great replacement for percentages when you're inside of grid math, because they're never going to expand too far to break your grid. I say never. There's probably a weird situation where you could force them to. Yeah, if you figure that out, tweet it at me or something. That'd be cool. But what if we want to line things up inside of the grid? You're used to maybe align and justify from flex. In grid, it's better because they make more sense. We have justify content and justify items, align content and align items, and they do things in a more manageable way, or maybe they just feel more manageable to me because I did flex for a few years before I got into reading grid spec stuff. So anyway, justify content says, how are we going to distribute the tracks within the grid parent? All the columns that we're creating, how are they going to be distributed inside of the grid parent? If you do 3 columns at 30% each, you've used up 90% of your space, you got 10% remaining, right? You could do a gap to use up that 10% remaining, or you could tell your grid, justify content, space between. Feels a lot like Flexbox. And what it'll do is it'll slide everything to the edges and leave gaps between. Any undefined space will be added to the gap area. And it has a bunch of flex looking values as well. Again, if you've used Flexbox, a lot of these keywords probably seem to make sense. Stretch is what happens by default. The track fills whatever it needs to take up the space, as long as it's a fluid measurement. Start aligns it to the start edge of the grid container. End shifts all your columns toward the end of the grid container. Center puts them in the middle. Space between flings your farthest ones out right to the edge. and then divides the gaps up between all of the inner areas. Space around puts half a gap on the left and on the right, and divides the rest up in full gap measurements on the inside. And space evenly does full gaps on the outside and the inside. You say, wow, that's a lot of different things for those space prefixed ones, and you're absolutely right. And you know, there is no shame in needing to double check NDN when you go to use those in real life. Those are things that I have memorized tonight because I've been preparing for a talk. And if you caught me on the street on any random Tuesday and said, hey James, tell me what space between versus space evenly, you know, it's a 50-50 chance if I remember it or not. I'd like to think that I would, but I'm not promising it. Part of being a web developer is not memorizing all of the specs, but knowing how to look things up. So how does justify content happen in real life? Initial is just stretching everything, and so is stretch, go figure. Start shifts all of our columns, and these are columns that are not forcing themselves to line up too wide. We're not stretching them. So each column right now is taking up the intrinsic width of its child element. And they're set to 3 columns and they repeat. End, we'll slide them all to the right. Center will, as described, center them right in the middle. Space between moves our farthest ones right to the edge. Space around does a half a gap on the left and the right edge and full gaps in the middle. And space evenly does full gaps right, left, middle, everywhere. That's how you tell your grid where its tracks need to go. But what about aligning a child element within the column that it's defined, that it's supposed to be in? You can tell child elements which edge of their grid column or grid row to slide toward. Again, we're in justify, so we're working with columns. This distributes a child element inside of its track. The track is still set up like however you set it up, default stretch, or maybe you've modified it. This tells the child to zing itself to either the right or left edge of that column that it's in. If your child is already set up to take up 100% of the width, you're not going to see anything different, but if the child is allowed to be narrower by its intrinsic width, it will leave a space. So again, things like start, end, center, stretch. It's always better to see it in real life, right? So stretch is what's happening already. Each purple rectangle is taking up its full column width. But what if I tell it to align itself by the start? Our columns didn't move. The child element inside of each column moved. Columns or tracks, rows, those things are an abstraction attached to the parent element. The child element inside gets placed in one of those abstract boxes, and you're allowed to tell the child element which end to slide itself toward. It's kind of a tricky concept. Justify content moves the tracks around. Justify items moves child elements within those abstractions, within the track itself. The track is not a real thing you can select in your dev tools. Chrome, Firefox have fantastic grid dev tools. They'll draw little lines all over everything, show you where every track is, where every column starts and ends, all the gaps. It's super. Makes it easy to debug this kind of stuff. And if we inspected this, we would see blue dotted lines outlining every column at full thirds of our grid, gap notwithstanding. And then the elements are shifted to the left edge of the column they live in. The column is an abstraction, it just lives in code in the browser's brain. The element itself slides to one edge or the other. Anybody want to guess what's going to happen if I click end? Yeah, to the right. And center, of course, drops each child right inside of its container. Incidentally, since all of our measurements are the same and we're using 3 even columns, justify item center does visually the same thing as justify content space around. That's coincidental. That's not like a math thing you can bet your life on. If you changed your grid measurements and had some at different widths, it wouldn't do that. But since we're using even columns, coincidentally, that happens to line up. Now that's columns. What if, oh, go ahead, question.
Going back to the left to right versus right to left format, do the keywords, is it still like end, talking about the right, even if you're working with the right to left format?
Yes, if you're using start and end, it will respect your language direction on your page itself. So if you switched it to an Arabic translation with a matching layout, your browser would swap both the direction of the grid row and start and end would correspond to the language's intrinsic direction. You can use left and right keywords. I didn't put them on the slide because they're pretty self-explanatory. You probably didn't even need to look them up on NDN. That would be useful if you wanted to make sure that the the grid layout did not change at all, even when the page flipped to match a different language requirement. The use cases for that are probably relatively slim, but if you had one, left and right will ignore language direction if it's changed to RTL. Start and end will respect the RTL direction change, and they'll swap from left to right and right to left as well. Same things happen with the align prefix, only on the row direction now. So justify content told all of our grid tracks how to line themselves up, all the columns how to behave. Align content is going to tell all the rows how to behave, how they should line themselves up inside of the grid container. Again, same set of values: stretch, start, end, space between, space around, space evenly. Initial just has everything up at the top. Stretch behaves the same way. Again, I've got a fixed height in these. Sorry, there's a gap at the bottom that doesn't go away. But if we do start, now all of our rows are the smallest intrinsic height for their child elements, and they've all shifted to the top. End will shift them all to the bottom. Oh, here it doesn't care about the gap at the bottom. Thanks, CSS. Center will put them right in the middle. Between, around, and evenly do respect the unnecessary gap at the bottom. It's just end that doesn't care. It's like, yeah, whatever, we're going to drop it. So that's align content. We're changing the actual rows in the abstraction we call the grid. If you wanted to leave the rows alone and just line up the individual elements that happen to be within a row at the top or bottom of their row boundary, you would, as you might guess, jump to align items. And that's exactly where we're jumping to. Same set of values. We've got baseline involved here now too, since text elements have a baseline in CSS. First and last, we'll define which text element inside of a container, like if you got a div with a headline and a paragraph and description, which baseline to use to line up all your elements with each other. That can be kind of interesting. I'm not going to demo those because the baseline use case is super duper slim. But initial just has everything filling its row. Stretch does the same thing. Start, the rows don't change. They're still the top half and the bottom half. But the elements inside of them are now reducing themselves to their own intrinsic height, their natural height just by normal block model stuff. And they're shifting all to the top. And with end, we can send them all to the bottom. And with center, we can drop them right in the middle. Any questions before we leave all of our alignment things? This is, if you're gonna breathe, stretch your elbows, whatever, that's the end of the new properties for a grid container. Boom. That's one zone of the talk wrapped up. We've got new values too. So, any questions before we jump into the values? Just give you a quick second for a pause or a, yeah.
Can you just repeat one more time, how safe is this to use?
Yeah, if you're supporting modern, like last year's worth of Chrome, Safari, Firefox, you're golden. Mobile Safari 2, which is buggy in places with Flex that desktop isn't, but in Grid it's decent. Recent Android, once they quit doing like Android browser 4 point whatever and switched to numbered Chromes and it all became evergreen, it's good there. Edge accepts what I've tested out and tried, pretty much every Grid property that I've needed to use. IE11 has an old version of Grid that it supports. It has a whole bunch of prefix properties and they're all different and they're weird. And the only way you as a human with a normal brain are going to do those is with auto prefixer. So if you have to, you can add prefixes to cover most of your use cases with IE11. The biggest breaker with IE11 is it doesn't care about gap at all. You can't use grid gap with IE11, it'll just collapse it all and just smash everything together. So that's a use case and you feel really sad, you can put like margins on elements and that'll get you there. Or you can create grid tracks to match the gap you want. Instead of like one fraction, gap of 20 pixels, you can do 3-column grid, 1 fraction, 20 pixels, 1 fraction. And then you just have to change all of your grid column measurements. And there's a cool thing, remember the named areas where we can put words like header and footer in there? If you put a period in, the browser knows period, that's a reserved keyword. Period means skip this zone. You're not going to assign any content to this. We're just creating a dead space in the grid area. So anyway, that's a rough IE11 hack if you need to go there. Yeah. Yeah.
You can also use polyfills as well, right?
I have not tested out any polyfills. The trouble with polyfilling CSS is if we could do that with different CSS properties, we would have just done that. So typically you're writing fallback code. You can write display table to cover IE11 if you need And you can use the @supports query, which we covered like 3 or 4 of these lessons ago, to test for CSS Grid support. And if you do that, you can give Grid to the good browsers, and everybody who doesn't support Grid or @supports gets whatever your fallback layout is. And this is a great place for you to make a business case to your management team, your client team, whoever you're talking to, for in the old crummy broken browsers that shouldn't even exist anymore, it can look readable, it can be functional, but it doesn't have to be the exact pixel by pixel grid measurement unless we want to spend a ton more money on development time. Some cases you'll have a client or a designer turn around and say, yep, it's worth the money, we're going for it. Other cases they'll be like, you know what, everything's just going to be rows, we can live with that. It kind of depends on their metrics, their cost benefit analysis. You can present a good case and yeah, go with it from there. The thing there is IE11 supports a bunch of grid stuff from a previous iteration of the spec, but it doesn't support @supports for a feature query, so it will get the fallback if you put all of your grid code inside of an @support statement. One thing to be aware of. So we've got new CSS lengths. Anybody like lengths? I toyed with the idea of having a lesson in the series called all the measurement values in CSS, but I realized that would be just like super dry, and so we didn't. Any normal CSS length is a valid grid track, grid template columns, grid auto columns, grid template rows, grid auto rows. It's a valid track measurement. And those include all of our old favorites like pixels and percents and points and pica and inch and centimeter and millimeter and an M and a rem and a character unit and viewport width and viewport height and viewport min and viewport max. All of those are valid units for a CSS grid track. Well, we've got a new length, and we've already talked about this, and some of you have already figured out what it does, so I can basically skip this slide, right? No, we'll talk about it. The fractional unit gives us 1 fraction of the grid's available free space. Fraction, free, nice little mnemonic for you. And what it does is it takes all of the other measurements that have to be accounted for. Oops, I jumped ahead of my bullet points. After all the non-fractional space gets used up, that's things like pixel grid tracks, percent-based grid tracks, M or rem or whatever based grid tracks, all the fixed measurements, as well as gaps. Once you take all those things away, any available space is your available fraction zone. And then however many fractional units you've put in that same set of measurements, that same series of track values, that determines how much each of those columns or each of those rows gets from whatever space remains. So again, to kind of go over what we did before, if we did grid template columns, 1 fraction, 2 fractions, 100 pixels, the browser would say, first thing I gotta do is take away the 100 pixels. Then what space is left? Let me double check, is there a gap? We didn't use a gap, cool. All the rest of the available space, all those remaining pixels, gotta cover 1 fraction and 2 fractions, so we divide it by 3. And we assign 1/3 to 1 fraction and 2/3 to 2 fractions. And that's how the browser handles that math. It's a new unit, it's just for grid. I don't know if there's a use case or any plans to bring this into Flex or not. It seems like it could be kind of cool, but also Flex Grow and Flex Shrink with different integers cover a very similar use case, so I don't see a huge need to put this into Flex. And here's the part where I come back to the question asked earlier about what if you have fractional units in a grid, in rows, in a grid with no fixed height. The grid is natural height. So here what we have is a grid, and I will give us bigger letters to look at. That's cool, I don't need JavaScript. So here's our grid template rows. 1 fraction, 2 fractions, 3 fractions. And now we can look and see what the browser has done over here in this grid. It created 1 fraction by asking itself, the 1 fractional row, how big does that need to be? And it says, okay, it's this paragraph and it's got this padding around it, which is 1 rem, and no margin to worry about. So whatever this line height is, plus a rem either direction, that's the minimum height for a 1 fraction row. Again, how does it know it's a 1 fraction row? Because it's in position 1, and because our first row measurement is 1 fraction. Cool, I've now got a grid row that's 2 fractions, double that number. However many pixels it was in row 1, double it. However many pixels it was in row 1, back where we defined a fraction, triple it. It seems a little weird, maybe a little counterintuitive, because now 1 element gets to choose what's going on for all the rest of those rows, but that's how it works. The intrinsic size of whatever element ends up being 1 fractional unit ends up making the rest of the rows take up the right amount of space.
It'll be fluid, right? So if the text on the top row wraps, that will cascade out to
Yeah.
the other two.
Yep.
It's a lot of really crazy metric math.
Yep. Yeah, that corner.
Just switch the 1 and 2 real quick.
Yeah, we can. Again, it finds the one that matches one fraction in its little rendering engine and says, what's that height? That's going to be one fraction. Everything else has to multiply by that. If the, yeah, go ahead.
Not to like jump in on your talk, but I found it pretty interesting when the smallest value was 2 FRs. So when you had both the first and the second as 2 FRs, it has the, I mean, it sets the 2 FRs as if it was the 1 FR value.
Yes.
Which is, I was kind of curious as to what would happen, even though it's a pretty strange use case.
Right. What we've done here is good thing to point out. Now the first and second paragraphs are the same height, right? But they're each assigned 2 fractions in the grid. So what's 1 fraction? Half of that height. Multiply that half by 3, and now the third paragraph is only 1.5 times the first one and the second one.
What if those two are different heights?
The browser, I believe, will take the largest one, and that'll be the minimum. At least that's what should happen. We can test it out. My thing's too big to see everything. All right, there it goes. So we'll just double it. And since we really need to make sure we see a difference, triple it. Yeah, so 2 fractions still equals 2 fractions. The first 2 rows are the same height, but now 2 fractions is based on the height of the largest 2 fraction option, and 3 fractions is 1.5 times 2, so the third row is 1.5 times the larger of the 2 fraction assigned rows. Well done, we've gotten deep endy stuff. This is fun. So that's fractional unit. Any questions about fractions? Again, they're really awesome. They're the new way to be awesome and fluid in a grid. If you wanted to do a design based on our traditional 12 column grid, you remember that from like 960 GS and all those old cool things, and then Bootstrap did the same in Foundation, and every designer, and almost every designer, has got a 12 column thing they just slap onto Sketch or Photoshop or wherever they are. You do grid template columns, repeat, and a repeat function, which we're going to cover in just a second, 12, 1 FR. You don't have to figure out what 100% divided by 12 is and how much you should round your math. No more that dividing by 3 gives us fits. We're cool. We can use fractional units and it just works. So all you need to do Bootstrap is grid template columns, repeat 12, 1 FR, and grid gap of, whatever that is, like 16, 20 pixels. And boom, that's the exact Bootstrap layout with 2 lines of code, well, 3 lines if you do display grid. And then you just assign the children to match, yeah.
Then you can also tell your children where they can sit within that 12 column.
Yep. So there you go, there's more fractions. Again, you mix them up with everything else. The bottom one is really fun. Again, you don't have to use an integer, you can use a float. And in that case, the browser can be like, I need 3.2 fractions, divided the available space by 3.2, give 0.6 of that to the first one, 1.6 to the second one, and 1 of it to the last one. And you're asking for complication issues at that point. But the great part is, Grid just does it. You have to make sure you give it the right values on the way in, but it just handles the math and it fixes all those extra space issues for you, and it's just clean and nice. We've also got some new keyword values. This is not a unit, it's a keyword, min content and max content. Do you know how an element displays when it's display inline block? When it's block, it goes 100% of whatever its parent width is. That affects width. When it's inline block, it only gets as wide as it needs to accommodate its content. Min content and max content let us make a grid column match its child element with the same rule in mind. What does this child element naturally do? That's what I'm going to make the entire column for the whole grid. These define for us the smallest and the largest space that the element in that track needs to take up. And that's a whole bunch of words, so let's look at it visually, because that's way, way, way more better. So the first one uses min content, and I want to make this, I got to move the projector one of these days, right? Throw a broom at it. So anyway, we've got a rather short paragraph at the beginning, and that's a grid column that's set to min content. What does it do? It finds a minimum space that it can squish that element into, respecting normal things like word breaks and line breaks, spaces and hyphens, but not crushing any words or letting anything overlap and hang out. If you had child elements in here that had their own set widths, the rules would bubble onto them, drip onto them, and they would be setting that parent grid thing. So since paragraph colon is the longest word that can't be broken into a shorter unit, min content squishes the entire column down to the length of paragraph colon. Max content, on the other hand, says, what if we don't force any line breaks? Now what's the narrowest we can be to accommodate the whole content at its max width, no line breaks involved, no wrapping. And so that's what it does. It doesn't wrap anything, but it cuts off the column width at the exact end of that final letter T. When you use things like this, if you've got like a responsively sized image inside of a grid and you wanted to control the entire column's width, you could do that, and then you would set the column to either min or max content, depending if your image is focused more on growing or shrinking in response to constraints. And that would set an entire column of your grid based on, in this case, the image is not line breakable like text would be. So the image would usually, unless you got gigantic words in your paragraph below it, that image would then set the entire grid width according to its own intrinsic width. Min content and max content. And again, we're a little bit in the fringy zone. You don't probably use these in like 90% of your grid, but every once in a while, remember what they do, find them on MDN, double check the spec, yeah.
CSS, can you pull it up so we
So yeah, in both cases, we've got display grid and a background color. Then the first one is grid template columns min content, and the second one is grid template columns max content. And what that does, it creates one column in the grid, doesn't care about filling empty space. It's fine leaving empty space if it has to. And then the one element inside of them, that the only thing in each grid is a paragraph, constrains or controls that column width. The content controls the width of the column rather than your explicit declaration on the grid parent. I mean, this is an explicit declaration. You're telling the grid parent, make this column min content, but you're telling the grid, you have permission to let the child control this width. Or if it were a row, control this height. If we added a whole bunch of content to somewhere in here, like we made our short paragraph significantly longer, max content is going to fly all the way out to the edge. And again, you can make grids that are way wider than their parent element. If you're thinking in other CSS properties, max content sure behaves a lot like white space no wrap here for our purposes. And that's basically what's happened. We've created a grid column that's way wider than its parent container should have been, but because there's no constraint, that's the width we get. If we made our grid, gave it a fixed width, the content would still overflow. That child element is still overflowing its parent. And if we gave it padding, we would see that the parent element does stop at a certain point. We're not using box sizing here, so the padding is goofy. Yeah, the child element way outflows the parent. We haven't changed the grid's width, but the column inside is way wider than the grid allows, so it just overflows. Is that useful? Yeah, you ever seen like an image slider kind of thing? Okay, everyone loves to hate on carousels, and we absolutely applaud that kind of hating. But if you had to create a horizontally scrollable element, you can use grid, create a whole bunch of grid children that way exceed the parent boundary, and you've created a scrollable container as long as you put like an overflow scroll property on it. So yeah, grid is really neat for creating overflow scrollable containers with just a grid container and not having to worry about white space and then undoing the white space on the child and a whole bunch of more complicated CSS things. So that was a little bit of a rabbit trail that followed after min and max content. If we made min content much longer, it's still never going to get wider than the word paragraph because there's nothing wider than the word paragraph. So we could put as many copies of this text as we wanted in here, and it would still only be paragraph colon wide. Because it's doing line breaks, and it's never going to get wider as long as it keeps breaking between words. Yeah?
If you put white space no wrap on the min content, it would act like no
Yeah.
respect the white space.
Mm-hmm. Yep, and I can kill that padding in. Yep, now they've become identical. That's min and max content. We've also got a function called min-max, which says let the container, let this track, row or column be fluid in its height or width, whatever it needs to do, but it can't be smaller than the first value I'm about to give you, and it can't be wider than the second value. Min and max kind of makes sense that way. So it gives it a good relative value between those two lengths, usually based on content's auto width. But again, it caps it. So in this case, the column I'm describing, I'm just going to use column as my example through most of this, is never going to be smaller than 10 pixels, even if you remove every element inside of it. It's still always going to be a 10 pixel column, but if you fill it with tons and tons of paragraphs, it's never going to get wider than one fractional unit on the grid's available fractional space. So yeah, min-max, again, these are kind of the complicated ends. If you're doing a lot of grids with min-max, congrats, that's cool. You're working with some really creative designers probably, or just really specific constraints. I don't use min-max every day. I don't think I've ever deployed it, but cool to know about. Fit content is like min-max, but the first value is always auto, and the max content is whatever you pass into fit content. So you can pass a clamp argument into fit content, and that just overrides the max content number here. So again, min-max, where the minimum is auto, but the maximum is whatever you give it. You can accomplish roughly the same thing if you use like an intrinsically sized grid, just auto for your column width, and put a max width on every element that ends up in that column. But again, we don't want to be sizing all of our column children. That's the whole point of going to grid. So this would let us create a grid column that will be as wide as it needs to be to accommodate its widest element, but never wider than, say, 300 pixels if we pass that in as the clamp, the max width. And if we don't pass anything in, if we just write fit content empty, it will use that max content keyword we looked at a moment ago and never go beyond the necessary max content value. Repeat, we've already talked about. That takes two values. The first one is an integer, not a float this time. You can't repeat a number 1.2 times. An integer and then a value, and that value, that measurement, gets repeated your set number of times. So again, repeat 12.1 FR and you've got a Bootstrap compatible grid. There's a really great article on the interwebs. You can find it by Natalia Shelburne, working at New York Times, about how she started converting their layout from Bootstrap to CSS Grid, and the incremental tiny steps she did to make sure that she could do this entire change without disrupting anything and without making any stakeholders upset because a column was no longer the right width. So really, really creative article on practical use case stuff. But repeat 12.1 FR gives you all the right measurements.
Yeah. Natasha, what?
Natalia Shelburne.
Natalia Shelburne. Cool. Thank you.
And if I remember, and if I don't, somebody remind me if you're curious, I'll try to remember to post the link in Meetup later, tonight or tomorrow. Now here are two really fun words. Autofill is on this slide, and the next one's gonna be autofit. And those sound really, really close. And like, most people know that there are two different things, but how do you know which one is which? Let's talk about it. Autofill and autofit are both keywords you can use instead of a number in the repeat function. Autofill is not a function of its own. I tried using it that way a few times and realized that that was wrong and I was mistaken. Autofill is an integer keyword for repeat. It's a good count value. And what it does is it repeats the second parameter in that function as many times as it needs to until the current the current row or the current column is filled. So in this case, repeat autofill. We'll do a min-max value, that's our measurement. Minimum 20 pixels, maximum of one fraction, and it'll create as many of those columns as it can until our grid is filled. This is great because it's totally responsive and it doesn't need any media queries and things just snap to filling the width. We'll look at an example of this in a moment. Autofit does the same thing, but this only repeats the value until all the children are accounted for. Autofill creates grid tracks until the grid parent can't contain any more tracks, no matter how many child elements need to fill those tracks. Autofit stops repeating as soon as you've used up all the child elements, which results in different layouts. What do you mean different layouts? Well, glad you asked, because we have a visual for that too. So here's autofill and autofit, and at the moment, what's the value that's being repeated? Min-max of 201 fraction. Oh, just like I had on the other slide, how convenient. But the first one is autofill. It's going to keep creating tracks that measure min 200, max 1 fraction until the grid is full of tracks like that. As many of those tracks as it can cram in, it will, even if there's no children to fill them. Autofit, however, will say, oh, I've got 3 children. I'm going to create 3 tracks. And I'm going to stop creating grid tracks. And it's going to show us different layouts, as we'll see in just a second. And if I zoom out. So what has happened here? Oof. Min-max of 200 or 1 fraction. So we've got minimum 200, 200, 200. There's room for another 200 here, another 200 here, another 200 here. It keeps on creating grid tracks even though there's no content to put in them. But in the second one, it says, oh, just give me 3 things that are minimum 200, maximum 1 fraction. Since max 1 fraction can be as tiny as it has to be, as many fractions as you want to cram in, it keeps creating tracks as soon as there's another 200 pixels of space available. If we kept on expanding this and made it another 400 pixels wide, we would get 2 more tracks that were empty. But because the second one stops creating tracks after it has 3 children covered, it's good. It's all the children elements I need to fill. We're done. What it will do is each of those 3 children will be min-max 200, max 1 fraction. And in this case, since the grid didn't create additional empty tracks, 1 fraction just means a third. And so in the bottom row, these are expanding their parent element totally. It's great, it's awesome, they're big. There's no empty space. That is auto-fit. It fits the available children to the space that's allotted for them. Autofill, though, keeps cramming in more grid tracks, that abstraction on the grid parent, even if there are no child elements to be content to fill those columns. Why would you choose one or the other? That's up to you. Compare your design. If you've got a design that needs to leave empty rows, autofill might work for you. If that pixel size of an element is the more important detail. Even if there's empty space, autofill will get you in a better place. If the goal is just fill up every row, no matter how many children are in it, great. Autofit is better for you. Yeah.
This might be a little bit too much of a tangent. Can you style or put a background color on the empty cells?
No, but what I can do is inspect it with the grid inspector, which is a lot of fun. So in DevTools, browser ain't in, garbage browser. In Chrome, this should work. Oh, there it is. Chrome removed the icon you click on, and all you have to do is hover. So can you see the dotted lines? It's drawing the dotted line around every track in the grid.
But you can't style that visually without.
Correct. You have to put something in there to style it. And that's something that people are sometimes frustrated or stymied by in grid. They want to style zones. They want to style tracks, columns, or rows. You can't style that because it's just an abstraction. It's not a real thing you can attach styles to. Or it's not a node. It's not in the DOM. It's just a track, a concept, an abstraction that's attached to the parent. Some people are pestering browser vendors and requesting this in like Grid 2.0. Let's get the ability to style a named grid area with at least a background color, a border, something. But that remains to be seen whether or not browsers allow that.
Look at the treatment, like they do it before and after. You have the track.
Yes, now you can throw before and after into a grid and they will take up space as child elements. They will snap to grid columns just like a paragraph or a div or a span would have. So yeah, that's autofill and autofit. If we snap it down further, what happens if I can't fit 3 of these at 200 pixels each across the grid? Now we see behavior again still the same because we don't have an issue of cramming more tracks in. The minimum value is still going to be 200 pixels. So if the grid container gets too small to allow 3 of them across, the line will just break. It'll start a new row. And again, it'll still be minimum 200 pixels, maximum 1 fraction. And because again, it's a grid, it's controlling columns and rows. It's not flexbox. The bottom child doesn't automatically become 100 pixel or 100% wide, and you have to fix it with math and an nth child selector. And if we got even narrower, everybody would be 100% wide. Because the minimum is 200 pixels, but the maximum is a full fractional unit, whatever available space remains in the grid. Some of you are thinking, well, this is wild. We can do like responsive components without media queries. Yes, this is one of my favorite parts of Grid. And I've got a slide that shows a little more of that in CodePen later on. You can make components with responsive layouts that respond to their own size, not a media query, not the viewport, by using autofill or autofit, whichever matches your use case better. That's autofill and autofit. Cool. That's everything you can do to a parent. A couple things I omitted because they were just shorthand for something else, but that's the way you treat parents. Anything else? And I'm going to try and speed through the rest of it because we are at 8 o'clock already. And by the way, let me free you all up. If you're like, I got places to go, man, I get you. Walk out, nobody's mad at you, you're fine. So nobody needs to feel like they have to stay longer than they need to. Yeah.
Can any of these be animated? Like, can you slide these boundaries around?
Right now, you cannot. Firefox has a little bit of pre-support for changing column proportions or row proportions behind a flag, I believe is where it's located. So they're kind of starting to move where if you change grid template rows and grid template columns with transitionable math properties, math numbers, those can be transitioned eventually. But for now, that's just fixed. You can't slide an element from one grid position to another. That would be fun too, but that's also not a thing we can do yet. Partly because grid cells are different widths, different heights, and that will cause content to reflow inside, and that's just a nightmare for the rendering engine to try and animate all of the things that change in a particular grid child. So what we can do to the child is a lot less because, as I've already mentioned, most of the complexity lives on the parent, lives on the grid itself. In fact, there are only 6 relevant properties that are helpful to know. Grid column contains 1 or 2 values, the column it should start with and the column it should end with. And these numbers, this is a tricky part of Grid 2, these numbers don't correspond to columns as you count columns across, like 4 columns, cool, 1, 2, 3, 4. These numbers you're going to use match the borders of the columns, the edges. So if you've got 4 columns in your grid, you've got 5 edges, pre-1, between 1 and 2, between 2, 3, between 3, 4, and post 4. You've got 5 edges, and that's what the numbers that go into grid column actually measure. Oh, cool. You already knew that because we said that out loud. So the second integer is optional. You separate them with a slash. So you can do grid column 1/3, and it will start at the first column edge, and then it will go 3 edges in. And so it'll be 3 columns wide. It'll go to the 3rd edge and stop there. You can use a span keyword in front of that second number. You can do 1/span3, and that won't go to the 3rd line. That will span 3 areas, no matter where it started. And we've got some examples for that in a second. Grid row does the same thing, and these are shorthand for grid row start, grid row end, and column row start, column row end, and you can use the expanded versions if that suits your fancy, and that's easier to modify later on in your code. Same thing, integer/integer. Grid area is my favorite one. This is where you put the name of one of those named grid areas we drew back in grid template areas. If you're going to ASCII art your grid layout into a nice little visual image, here's how you get a hold of those names and assign elements to the named areas. However, it can also be shorthand for row start, row end, column end, and I don't get that. I mean, I get that. Like, I understand when I read it what it's doing, but it's not the way my brain goes. I want to go across columns first because CSS always does horizontal first and vertical second. And I want to do both of my rows first and both of my columns second, but it has to go this order because of which are optional values. You have to have start values. End values are optional. So you have to get both of your starts out of the way before you can do both of your ends. Anyway, I could read that and I could write that, but I don't like it. So I like named areas better. Or I just don't use a shorthand. I prefer grid column and grid row. But again, if you needed to cram them all together into grid area, go for it. But I would recommend this, set up a style guide for your team. So grid area only contains numbers or only contains named areas. If you start mixing them up, you got a lot of mental overhead, and your team is probably going to get a little slower in the the measuring and remembering all that side of the work. So grid column 2 now moves it over, so it starts at edge number 2. 3 would do the same thing. We do 2/3. Okay, default is just 1 column wide, so we do 2/4, and now it jumps out to the end. Same thing for span 2. Grid span 1, again, span 1 is kind of the default, so we could also do, thanks caps lock, grid row, and again starts on row 2, spans 1 row, starts on row 2, spans 2 rows, or starts on 2, skips to 4. I'm kind of moving through these quick, partly because the numbers are usually way less important than the named areas. I recommend going with a named area approach. One cool trick we can do here is, go back to grid column. What if you want it to be the full width no matter how many columns there are? Can you do that? I just want you to start on 1, I want you to skip to the end. Yes, and use -1. Any number you want to start at is great. You can do, whoops, there's no 12, 1, 2, or 3, and putting a -1 in the end part of the property will just make it skip to the end. The final row, the final column, it'll just jump to the end. This is really cool if you wanted to align a bunch of things to the right side of your page, or left in a RTL language context, but start them at different places, give them different widths. Yeah?
You did like 2 and then -2, would it shift it?
That's a fun question. We can see real quick. Oop. Yes.
Oh,
Negative just starts at the other end and measures in. Yeah. So if you went Ghostbusters and crossed the streams and got a negative that was wider than the total grid, I don't know what'll happen there. We're not going to test that. That sounds like fun though. Or we could do grid area, grid, and do 1, -1, -1, and -1. Now it covers the entire parent grid. Start of the first everything row and column, end of the last everything row and column. So those are grids with numbers. You remember Flexbox in the order property, where you can slide things around visually no matter where they are in the DOM? Yeah, that works too. Changes the element's location along the main axis. So if you're going across a row, you can move an element from the end to the beginning with the order property. It takes an integer and it's relative to all of the other orders. The default is 0, I believe. It might be 1. Double check that on your own. Remember align items and justify items? Looked at those earlier. Telling all of the children in a grid how to align to their track, top or bottom, left or right. What if you needed to override that global on just one child element? Align self, same set of values, justify self, same thing. I want everybody at the top of their grid row, except this one element goes to the bottom. Cool. Justify items on your parent, start. Align self on that one oddball element, justify self, end. And for the sake of time, we're not going to play around with a whole bunch of things, but it's worth pointing out accessibility issue. If you go changing order around from what's in your DOM, screen readers and keyboards don't care. If you've got tab or keyboard focusable items with a native tab index or tab index you've added, and you go rearranging their order with grid properties or Flexbox order property, your users are going to get confused because they're going to be tabbing through and they're like tab, 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 and they're back in the middle. And their tab is still going to respect the DOM order. It's not going to, it doesn't care what the CSS order properties are. So be careful. Only use this kind of thing with like purely visual stuff, sorting the order, or elements that have no tabbable content. Even then, careful, screen readers are still going to read things in the DOM order. They're not going to read things in the order because, again, that's one of the CSS properties, like most CSS properties, that a screen reader simply doesn't care about. It doesn't care what order you've put on things, it's just going to read it like it's in the DOM. So what about use cases? Last section, this is the practical stuff, we're going to zip through it. Okay, everybody likes the joke about Peter Griffin and the blinds, right? We've all seen the meme, yeah? He's yanking the blinds, nothing ever works, and they all break. And it'll be like, ha ha ha, center something in CSS. And that's a great joke, except that's all it takes. You do that to a parent element, and whatever you put inside of it will be perfectly centered, horizontally and vertically. Boom, 3 properties, you're done. And there it is, happening in real life before your very eyes. Global grid layouts, what if it's on 3 columns everywhere? Cool, 3 columns, 100% tall. Equal height grids, do a picture gallery, a set of cards, and like a shopping, display kind of a layout. Yeah. Auto rows or template rows if you know how many children you have, but auto rows is great if you don't know how many children you'll have. Let the grid keep making rows at the same height and just give it fixed column widths. Some other use cases, this is the one we looked at a moment ago. This is that old holy grail from CSS Grid that everybody like blogged their minds out about from like 2000 to like 2012 or something. Relatively trivial with grid. The body is display grid. The rows are min content, one fraction and min content. We've got some min max on the columns here, so there's a use case for you. But here I've even got an extra fraction column on the grid on the sides. So when our content in the sidebar don't expand their max width, we let a fraction be on each side. And if you put two fractions on the ends, it centers whatever's in the middle because those will be identical. And if a fraction has to get down to 0, the grid's cool with that. So yeah, it's a great way to center things pretty quickly when they have fixed widths that are still flexible. Here is the responsive components I mentioned to you earlier. Ah, no, it's not. I broke my link. I'm sorry. Anyway, this is a navigation where the logo is always at the left edge. I know, epic fit. And all the links are at the right edge, and you can do that with Grid. But I wouldn't. I would do it with Flexbox. It's easier. Did I put it here? Did I mix them up? Nope. I put the same link twice. Sorry. Oh, this is one where we need to look at Firefox because there it is. Okay, that's what I did. Anyway, these are the exact same markup, the exact same grid properties. There aren't two different CSSs here, other than the max width on these elements. But because this first element is so narrow that it can't accommodate both columns side by side, and they're min-max to a fixed minimum and one fraction maximum, the content just automatically switches. You've got image on top, text on the bottom, when the element itself is that narrow. Who cares what your screen size is? Who cares about the browser? When the element itself is that size, the layout changes. And when there's enough room, it goes double wide here. That's the link that was broken that I kept trying to click on the other side. Let's see what else I broke. And this one, maybe I have the right URL. I do. Cool. This is a bar chart. This gets double fun because we're also adding CSS custom properties. We're putting each, it's tiny, sorry. Wrong direction. Each person's score in a score custom property, and then we're using it to lay out the grid. And in this case, it's responsive, and we're just changing the grid direction and grid properties to match a single media query. And that's nothing but markup. This is a definition list with terms and definitions. It's just text. This is all the markup. And credit where credit is due, Miriam Suzanne did a similar chart and several really cool things in a talk she gave here several months ago. And this pen is linked from the slides from tonight, which I'll post later. And then in this pen, there's a link to her talk. And the last one, we had a client who wanted to lay out a bunch of images in a spiral. And this is really goofy. Because when it's big enough, the center image should be 3 by 3. And then we're going to rotate in the spiral 2, 3, 4, 5, 6 in your, I don't have to count out loud. And it loops all the way around in this clockwise way. So what do? We put grid on there. We do named areas. Again, it's all in one property. Let me. Oh yeah, so there it is. I'll go ahead and zoom in. And that's all one property. And then I change it for a media query. And that's all I do is change one property. When it's smaller, it drops down to a 2 by 2 square in the middle for the center photo. And then we stop showing pictures after the 33rd. And then in the narrowest, it's only 1 by 1 in the middle. And again, the spiral still happens. It's still rolling counterclockwise all the way out to the edge. But that's just one more media query and one more changed grid template property. That was a lot of fun. Unfortunately, my coworker who got to implement that one doesn't have grid as a safe support base requirement for what they're working on. So they had to work with an engineer to parse all the images that came back in order from an API and put them all into a bunch of Flex containers. And I cried when I heard how they really did it. But job security for the Ember dev. So yeah. The calendar is just like a daily calendar view with a whole bunch of events lined up, and it's the same thing, CSS properties and a grid layout. Sorry, I don't have the link correct. Yeah, and that brings us to Flexbox versus Grid. I said this already, Flexbox is 1-dimensional, Grid is 2. You can control both columns and rows. A ton of resources, I won't read them all to you, look them up later. I'm James, I work at Dockyard. Corey works at Dockyard too. Dockyard is hiring. We're looking for an HTML, CSS specialist. So that's you, dockyard.com/careers. And if you want to talk more about the slides or ask follow-up questions, you can hit me up on Twitter, GitHub, my blog, JD Steinbach, everywhere. Thank you all for your patience, and appreciate you coming tonight.